Good afternoon, guys. So this is the next video of our lecture series in the voltage regulators. Here we will be talking about the types of regulators. As you know, we have already talked about the type of regulators in the introductory part of our video. Here you can see that fundamental classes of the voltage regulators can be divided into two categories. Okay, I would like to highlight both of them. As you can see, the fundamental classes can be divided into two categories. First one is the linear regulators and the other one is the switching regulators. Okay. So the two basic type of linear regulators means this one is the linear regulators and the shunt switching regulators, but in the linear regulators we are having two more categories. The two more categories are the series regulator and the shunt regulator. So we need to study all these, the series regulator and the shunt regulator. The series regulator is connected in series with the load and the shunt regulator is connected in parallel with the load. You can see in the diagram, I can highlight it for you. This one is the first diagram. As you can see, in this it is connected in series. This one is the second diagram, as you can see, and here it is connected in the shunt. So the first one is called off as a series regulator. This one is called off as a series regulator, and the second one is called off as a shunt regulator. I would like to highlight it with some different part. This one is called off as a shunt regulator. Okay, you all might have got it. So moving ahead, so you all are clear with all these type of fundamentals here. We would like to go to the next slide. So in the series regulator circuit, as you can see, we are having four elements, and those four elements are being given by four blocks here. So you can see the first element as the control element. In the control element, we are having a reference voltage. First we can go for the reference voltage, then the control element, and then the sample circuit. In between we are having an error detector. Now all of these we need to understand that what all are these. The control element is in series with the load between input and output. The output sample circuit senses a change in output voltage. The error detector compares the sample voltage with the reference voltage and causes control element to compensate in order to maintain a constant voltage output. So you all might have understood. Now, as you have seen that here there was all those elements you have seen, and you can see the control element can be anything. The control element can be an op-amp, it can be a thyristor, it can be anything. So I have taken an example of an op-amp in a series regulator, as you can see here. And what you can see here is that you can see here that this one is the control element. Okay, this one is the control element, and for that we have taken here the op-amp. We have taken here the op-amp. Okay, so this is the control element, and we have taken op-amp here for this purpose. And this full circuit gives you a series regulator. This is a type of control element where the full circuit which is being made. Now we need not to study this op-amp series regulator, okay, but then you need to know that what is the output voltage that will of this. So the output voltage we will be getting here is V naught is equal to 1 plus R1 by R2 and Vz, because we are using a Zener diode, that's why. Now likewise we can use a transistor in this as a series regulator, as you can see here. As I told previously also that we can use different type of regulators in between. So here we can use transistor as a series regulator. Okay, now here comes the shunt regulators. Now in the shunt regulators you can see the unregulated input voltage provides the load to the current. Okay, some of the current is pulled away by the control elements. In the load, if the load voltage tries to change due to a change in the load resistance, the sampling circuit provides a feedback signal to the comparator. The resulting difference voltage then provides a control signal to vary the amount of current shunted away from the load to maintain a regulated output voltage across the load. You can see here also we have highlighted everything. You see we have given all those different, like this is the control element what we are having there in the series one. Also here we are also having this one is the reference voltage, the comparator circuit and the sampling circuit, all those but this full circuit is in shunt here. That's what you want to tell here. Okay, now here also we have used an op-amp and that too in shunt, and there we have used the op-amp in the series. Okay, here we are using the op-amp in the shunt. The op-amp shunt regulation, we need not to study, but then you should be knowing somewhat about it. Then comes the transistor shunt regulator. We can use the transistor also as a shunt regulator here. As I told you, these are the examples basically, but because I am telling you, I am giving you in detail. Transistor shunt regulator is somewhat like this. Okay, the output voltage can be calculated here, the output current can be calculated here, the load current can be calculated here, and the current through the resistance can be calculated here through RS. Okay, so this is all for the series and the shunt type of regulator. In the next video we will be going through the switching regulator. Okay, thank you for listening.